All right, so on to the last section within the decimals. Um, One thing we want to be able to do is convert decimal into a fraction and vice versa, and then obviously compare a decimal and a fraction. Now remember that a decimal is really just a fraction that has a denominator that's a power of 10. So that's the way we need to think about decimals all the time, as being a fraction really. So let's do this. How do we convert a fraction like 7/8 into a decimal? Now the big question I usually have from students is, well, which one goes inside and which one's outside? What am I dividing by what? And remember that this number 7/8 is less than 1. So when I'm dividing it, I should be getting a number less than 1. Remember, the way I would read that, another way of writing it would be this way, that that's really 7 divided by 8. So when I write that, um, remember the outside number will be 8, the inside number will be 7, and then there's as many zeros here as we want to put down. And that's kind of the tricky part. Normally they're always there, but we don't write them down. Okay, when we're converting a fraction into a decimal, we're going to have to write them down. Now, we start off like we always did, but the key idea is how to deal with the decimal now. So if I look, how many times does 8 go into 7? Well, it doesn't go in evenly, right? 0 times. I need more numbers. So I leave my decimal, and now I consider the 70. How many times does 8 go into 70? Well, not evenly, but I need a number that's close there. So if I go 8 times 9, 8 times 9 is 72. That's too big, so I'm going to go 8 times 8. And 8 times 8 is 64. So now when I do my subtraction, that becomes a 6, that becomes a 10, that becomes a 6, and 6 minus 6 is 0. Bring down the next 0. Now, if and we just keep repeating this process, right? So how many times does 8 go into 60? Well, 8 times 8 was 64, so let's try 8 times 7. 8 times 7 is 56. So again, I'm going to have to do some borrowing. And that's a 4, so bring down the next 0. 8. 8 goes evenly into 40, so we would say 8 times 5 is 40. So I end up with no remainder, so I don't keep the process going. When I end up with 0, I'm done. We have what we call a terminating decimal. So if I was to convert this into a decimal, we get 0.875. Now terminating is just a fancy name of saying it ends. Okay, now really in terms of fractions, there's two things that can happen. I get something that ends or terminates, or I get a fraction that will repeat itself. Okay, and that's true of any fraction. So if I was to try 8/15, now the 15 goes into, well, let's talk about doing it wrong. How could I tell that this is wrong if I did it this way? Okay, and I start off, and again, you can put as many zeros behind as you want. And if you started off that way, you'd say, okay, 8 goes into 15 once. That leaves 7 left over, right? Now I'd have to put in the decimal and keep, but wait a second, think for a minute. If I have 8/15 of something, that's bigger than 1. That's more than one whole thing. And again, think of our pizza example that I've been working through the whole course here. If I have 8/15 of a pizza that's cut into 15 pieces, and I have 8 of them, I had more than a whole pizza. That's not right. There's something wrong with this. So no, 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 no. This is wrong. It's got to be the other way around. So I'm just going to slide that over there. Slide that over there. That's not right. It's got to be the other way around. We have 15 into 8, and again, put your decimal in and put as many zeros afterwards as you want. So 15 doesn't go into 8, so 0 times, so put my decimal. Now 80, it does go into 80. Now we might have to try this. Let's see, 6, no, that's too big. Let's try 5. Okay, now how do you know that's right? Well, again, remember we're multiplying now, so we're going to have to do some carrying. So 5 times 5 is 25. So 5, and I'm carrying 2, and so If you need to use your fingers, use your fingers. Keep track of that too. 5 times 1 is 5, plus the 2 is 7. Yep, that's going to work. Now, I'm going to have to borrow again. So that gives me a 5. Bring down a 0. How many times does 15 go into 5? Well, that's going to go 3 times. 3 times 5 is 15, so I'm carrying 1. 3 times 1 is 3, plus 1 is 4. What's that leave? That leaves a 5. Bring down a 0. Now we're going to have to keep going until we either have no remainder or the number repeats itself. So we're just going to keep going here. How many times, and this is sounding familiar, isn't it? How many times does 15 go into 50? Well, it goes 3 times. Wait a second. 3 times 15, I just did that. That was 45 with 5 left over. And it's going to repeat itself and repeat itself and repeat itself. So instead of keep going, we stop and we say, okay, this is really, as a decimal, this would be 0.5, but we don't just say 3, because that's not right. It kept going. So we say 3 and we put a bar over top, and that's to represent that 3 keeps repeating itself. Okay? So what happens if I give you something like this, where I say, okay, what about 3 and 2/9? So I give you a mixed number, and I want that as a decimal. Well, I'm just going to worry about the 2/9, because really this is 3 plus 2/9. So let's worry about the 2/9. So again, 9 into 2, decimal 0, 0, 0, as many zeros as we want. So how many times does 9 go in, or 9 go into 2? 0 times, right? So how many times does 9 go into 20? Well, it goes in twice, right? Because 2 times 9 is 18. So again, borrow, and that becomes a 2. Bring down a 0. Wait a second. 20 again? Well, guess what? That goes in 2 times. Yeah, it's repeating itself over and over and over again. So we would say that this is really 3 plus 0.2 repeating. So really, this is equal to 3.2 repeating, which means 3.2222222, right? Keeps on going. So that's how I would handle that. I know your textbook also shows the idea of rewriting that as an improper fraction and then working from there. But what you're going to find out is if you do that, guess what? It'll go in, 9 will go into that number 3 times originally with 2 left over. But you can try it that way too, but I think this way is a little simpler. So, lastly, what do I do if I want to change now the other way around? I give you a decimal and I want to convert it into a fraction. And really, we're just worried about terminating decimals. How do I deal with that? So what your textbook says is you want to multiply this decimal by a power of 10 so you get rid of it. Now, but you can't just do that without changing the value of the number. So what we do is we multiply the decimal by the appropriate power of 10, but we also divide by the appropriate power of 10. And that division gives us the denominator of our fraction. So if I'm looking at 0.45, I'd want to slide my decimal twice. Well, to do that, I'd have to multiply by 100. Well, so I have to divide by 100, because if I multiply and divide by 100, I end up in exactly the same place. So I end up with 45 over 100. Now, others of you might have heard it say just, well, look at how many numbers there are after the decimal. That gives you how many zeros are in the denominator, and that's also true. Now, like any fraction, it's got to be reduced. Got to be reduced. So what goes into that? Well, I know 5 goes into 45 and 5 goes into 100. So if I divide by 5, I will end up with 9 over 20. Now 3 goes into 9, 3 doesn't go into 20. No, that's good. So that's our fraction in lowest terms. All right, so what about one like this? Let me just move that up for us. 0.075. Now again, 2 ways of thinking about it. Let's stay consistent with the textbook here. If I was to take that, I would want to slide my decimal 3 times. So to slide it 3 times, I need 1, 2, 3 zeros. So 3 zeros in the bottom. So sliding it 3 times, I get 75 over 1,000. Now 75 is a big number again. So what goes into it. Now, I always, when I'm thinking 75, I think cents, 75 cents. 25 goes in there, right? So I'm going to divide by 25, both top and bottom. Now, if you wanted to start with 5, that would work. 75 cents gives me 3/4. Now, I'm going to keep the 0 there. How many times does 25 go into 100? Well, it goes in 4 times. So it'd give me 40, 3/40. Okay, so decimal 0075 is really 3/40. Now, what happens if I have a number that's bigger than 1? And we want to rate that as a mixed number. And what I would do, and again, it shows you 2 approaches, but I would think of it this way, as 8 plus 0.04. And I'm going to worry about the 0.04. So 0.04, I need to slide my decimal twice. So I have to divide by 100 too. So I'd get 4 over 100. Well, we just talked about 4 into 100. If I divide by 4, I get 1/25. Now, my answer wouldn't just be 1/25 because I also had the 8. So I would say this is 8 and 1/25. Okay, the last thing that we got to look at. How would I compare a decimal and a fraction? And there's 2 ways you can do it. You can either put both as fractions or both as decimals. And what I find is the problem with if you put them both as fractions, then you need a common denominator still. Whereas if you convert to a decimal, you can pretty quickly figure it out because the common denominator is built in. So I'm going to take that 4/9 and I'm going to rewrite it as a decimal. Okay, how many times does 9 go into 4? 0 times. Okay, so far they're still the same size. How many times does 9 go into 40? Well, 9 goes into 43 times. 3 times 9, oh no, wait, that's not right. Try again. Now, how do I know that wasn't right? Well, 3 times 9 was 27. That left me 12. That wasn't big enough. Let's try 4 times. 4 times 36. That's better. When I subtract, again, I'm going to have to borrow. So that leaves me a 4. Wait a second. I just did this, right? 40. This is going to be 4 again. So it's going to be 0.4 repeating. So it's going to look like this. So when I compare those two, 0.45 to 0.44444 repeating, well, it turns out because this 5, and I'm going to just change colors here, because this 5 is larger than that 4, the number that's largest would be 0.45 is largest. All right, so last section in decimals. Good luck with it. Finish that off. Let's get to the pretest.